Welcome back with another video on TryHackMe.com. This is Zahinazi and we are doing OAuth Vulnerabilities. So this is the third video in this series. In previous video, we had completed the task 6. We captured the flag. Now we're gonna move from task 7 to task 10 in this video. Hopefully by the end of this video, we'll complete this room. Awesome. Task 7, exploiting the OAuth CSRF in OAuth. So CSRF, as we already know, can be prevented if the state parameter is there. If state parameter is missing, then this CSRF can be exploited. The state parameter in the OAuth 2.0 framework protects against CSRF attacks, which occurs when an attacker tricks a user into executing unwanted actions on a web application where they are currently authenticated. In this context of OAuth, CSRF attacks can lead to unauthorized access to the sensitive resources by hijacking the OAuth flow. The state parameter helps mitigate this risk by maintaining the integrity of the authorization process. Vulnerability of weak or missing state parameter. Weak mean the state parameter is guessable or it is static. So in this case, it is weak. Or state parameter is not there at all altogether. The state parameter is an arbitrary string that the client application include in the authorization request. When the authorization server redirects the user back to the client application with the authorization code, it also includes the state parameter. The client application then verifies that the state parameter in the response matches the one it initially sent. This validation ensures that the response is not a result of a CSRF attack, but a legitimate continuation of OAuth flow. For instance, consider an OAuth implementation where the state parameter is either missing or predictable, a static value like state or a simple sequential number. An attacker can initiate an OAuth flow and provide their malicious redirect URL after the user authenticates and authorize the application. The authorization server redirects the authorization code to the attacker's control URI as specified by the weak or absent state parameter. Okay, practical. Let's see the practical. In this example, in this exercise, we will explore how the absence of state parameter in the OAuth authorization process can lead to CSRF attacks. You will need to use the attack box to understand the attack from both the attackers and the victim's perspective. We will be using the app mycontacts.thm, which is hosted on 8080 app that allows you to sync contacts from any platform. So we already have our attack box. Let's also open it in full width. So the first tab is the attack box. The second tab is the VM that is attached to the task. Okay, so we have both. Let's move forward. Okay, start the attack box. We already have done so. Button at the top of the task. This machine will start the split view. In this case, VM is not visible. I use the blue show split view button at the top of the task. You would be required to add mycontacts.thm and the coffee thm to etc host. So let's do that first. Let us see what we have in the etc host first. So this is mentioned here. So let's put so what we need to add, we need to add two URLs, contacts.thm and mycontacts.thm and coffee.thm. Let's copy paste better, save than sorry. Okay, so we will write at the end of the file. So this two arrow sign will do that, and then we need to mention it is host. Also mention sudo, otherwise it will not write. etc host. Done. Let's also do it for coffee as well. COFFE. Let's see this on the right spelling. Coffee.thm. coffee.thm, yes. Now let's see if the changes are there. Yeah, changes are there, as you can see. Let's open up the Firefox and okay. First, visit the website in the attack box. So this is the website, that means the client application. Let's put it here, and it is available, as you can see. Awesome. With the credential attacker. With the credential attacker. Why we are using attacker? Okay, so we are logging into the client application, not the OAuth provider. Okay, so it doesn't. You should not confuse the OAuth provider with the client application. Right now we are logging into the client application itself with the attacker username and password. Okay, all right. Now since we logged in, once we click on the sync contacts using OAuth, that means we need to log in to the OAuth provider in order to get the details here, I think. Let's see what they are trying to do. Once you log in, you will see the page that allows you to sync the contacts to the coffee shop app. Once the account are synced, all the current accounts from the client app are transferred to the coffee shop app account. Okay. If you click on the sync contacts button, you will be redirected to an OAuth authorization server with the URL like this. Okay. As a pen tester, you will notice that the authorization URL is missing the state parameter, suggesting we can use the same request for a CSRF attack. Here, you don't need to sync your actual account. Let's exploit this vulnerability to attach the attacker's third-party account to a victim account. Okay, so before we click any of this, let's not this one. Let's open the developers tool. Alright, I will go to the network itself and then I will click on sync contacts. So as you can see, it requested this one, coffee, then the response type is code, client ID is this one, redirect URI is this one, callback CSRF, my contacts, but there is no state parameter. Of course, there is no state parameter. So now we are on the coffee. We need to enter the username and password, which could be victim and victim123, and then log in. Then it will redirect back to this URL, which is mentioned here, redirect_URI here. So let's see what we need to do in order to do that. Okay. Exploiting the vulnerability. Without the state parameter, the authorization process is vulnerable to CSRF. Why it is vulnerable? So consider that. The application does not know which user or when we requested this authorization. Okay, so since we don't have any state, that means this URL can be copy pasted across any of the browser, either from victim side or the attacker side, and you will be able to move on with the flow without any issue. Okay, so state parameter should be there in order to protect the client itself. For example, without this state parameter, it cannot be used more than once. Okay, so if attacker is able to gather the URL itself with the state value as well, since we are using it, so attacker will not be able to use this state parameter, and that mean if he is trying to copy paste this URL in the browser because of the state parameter, the CSRF attack will be prevented, because on the authorization server side, because we already used the state parameter value one time, you cannot use it the second time. Okay, so this is how it should be protected. It should protect the CSRF. Okay. The authorization process is vulnerable to CSRF. The attacker can exploit this vulnerability by obtaining the victim's authorization code and sending it to the attacker. The authorization server won't have any way to determine whether the authorization code belongs to the attacker or the victim, or whether the request is coming from the attacker or the victim. Yes. Preparing the payload. To prepare the payload, the attacker must get his authorization code. This can be done by intercepting the authorization process by using the tools like burp suit or any other network interception tool. But save up this exercise, we have provided the link. So this is the link they have provided that allows you to get your authorization code without completing the OAuth flow. The code for the flow is pretty straightforward. Okay, so let's use that. In here, let me use a private window. Let's see what happens here. Okay, so what if we just copy paste here? What will happen? It will show the same window. All right. So this is how it should look like. The OAuth login CSRF. So this is the CSRF page itself where we will receive the request. Application.object.get. This is contact app itself, and then the redirect URL is the copy.thm CSRF callback CSRF.php. Authorization URL is this one. How we gonna use it? We are redirecting. Once we get back, we are getting the code from here. If there is no code, then we are showing an error. If there is a code, and we are putting the code and just returning the JSON response. You will get the following response once you visit the above shared link to get the authorization code with the credential attacker Tesla at 123. Okay, let's do that. So this is the first request, not the second one. Wait a moment. Where is the... this is the private browsing, so we are good. Attacker Tesla at 123. That is the password, right? Tesla at 123, yes. So once we log in, we authorize, and here is the payload. Here is the code itself. Okay, so I'm gonna copy this one and put it somewhere. For example, do we have let's create a, for example, nano. Let's create a code.text, and let me paste. This is code.text. I will press Ctrl O to write this one and Ctrl X to see if we have the code.text here saved. Awesome. And now I can minimize the private browsing and go back to the normal browsing here. Okay, the above authorization code would enable anyone to get an access token against it. The URL parameter in the response is the actual payload that we need to send to the victim's copy payload value, which we'll use while launching the attack. So launching the attack is like this. Once the attacker has obtained the authorization code, he can prepare the CSRF payload. Suppose the attacker sends an email to the victim with a link like this, bistro.whatever, and then the code itself. After receiving this email, if the victim clicks on the link or execute it in the browser where exercises the attacker's authorization code, the attacker's coffee shop app OAuth account will be linked to the victim's account. This effectively transfers all the content from the victim's account to the attackers. Okay, so victim perspective. In the attach VM, okay, which is our second here. So let me open a new tab. In the attach VM, to practically test it as a victim, log into the website itself with the victim. So now, before we were on the attacker side, and We have two. We have this one, and we have private browsing as well. So we already saved the code, right? So we are good to go. This is private, and this is the code that we use. Now we go to the victim's side. So this is how victim will access. Or here, this is the bistro.thm. So we'll use the victim here. Victim. Instead of victim 1, 2, 3, we are using victim. Okay. And now we are logged in with the victim. For the sake of access, since the authorization code is unique, execute the attacker's bistro CSRF code by pasting it directly into the browser. Okay, so let's do that. I will go to the victims and let me paste it here, but we need the code. I'll just copy it from here instead of the file that we saved. All right, and once I click enter, so you can see that we are successfully redirected back to the bistro, and now attacker access token is linked with the victim side. Okay, so this is our flag. So we put our flag here. We are done for the first task. As discussing above, the exact link sent to the victim in the URL parameter received during the preparing the payload process. Once executed, the code will make a call to the get access token and send contacts and messages to the attacker's account. Okay. What parameter name does the client application include in the authorization required to avoid CSRF? It is state. We know about this. Awesome. So let's move on to the implicit grant exploitation, task 8. Okay, in the implicit grant flow, tokens are directly returned to the client via the browser without requiring an intermediary authorization code. This flow is primarily used by single page application and is designed for public clients who cannot securely store client secrets. However, this flow has inherent vulnerabilities. Weakness: exposing access token in the URL, inadequate validation of the redirect URLs, no HTTPS implementation, improper handling of access token. So all of these are weakness. The first one is the application redirects the URL user to the OAuth authorization endpoint, which returns the access token in the URL fragment. Any script running on this page can easily access this fragment. Inadequate validation of redirect URLs. The OAuth server does not adequately validate the redirect URLs, as I told you before. So in case of implicit grant flow, the URL validation is not there in OAuth 2.0, but it is there in 2.1. Allowing potential attackers to manipulate the redirection endpoint. No HTTPS implementation. The application does not enforce HTTPS, which can lead to token interception through man-in-the-middle attacks. Okay, even if you do the HTTPS, sometimes the firewalls or the security appliance that you have put in place need to inspect the token itself. So what they do is inspect the token, decrypt the traffic of HTTPS, inspect the token, and then encrypt it again and send it back to the actual server. So this could be considered as man-in-the-middle attack even on HTTPS, but you are doing it for introspection of the token to make sure that it is validated and everything is okay. Because the token will be encrypted, that means nobody else on the website or the layers above the actual server will not be able to see what is passing through if HTTPS is hosted directly on the server side. Improper handling of the access tokens. The application stored the access token insecurely, possibly in the local storage or session storage. This is normal way of storing even in now, but if you store this access token in OAuth 2.1 on the client side, it is okay, because most of these vulnerabilities and weakness are patched, making it vulnerable to XSS attack. So this is the type of security vulnerability typically found in the web application. It allows attackers to inject malicious scripts into the web pages viewed by other users. These scripts can then steal sensitive information like users' cookies, session tokens, and or other sensitive data. So since this kind of script is running on the same website you are visiting, so there is no cross site attack. So what happens is, if you are able to do a stored XSS attack, that means even with course policies or any kind of other policies that you are using, which will restrict the JavaScript execution on your website, will be bypassed, and the code that you have written will still be executed once the user will refresh the page, if it is a stored XSS attack. Okay. Deprecation of the implicit grant flow. Due to these vulnerabilities, the OAuth 2.0 security best grant practices recommends that you can click on the link and go read out the article. We'll move forward. Recommends deprecating the implicit grant flow in favor of the authorization code flow with the proof key for code exchange. Now, the PKCE is the way to move forward. Okay. If it is not there in the flow with the OAuth 2.1, then the OAuth 2.1 will complain that it cannot move forward with because the PKCE configuration is not there. This updated flow provides enhanced security by mitigating the risk of token exposure and lack of client authentication. Practical. Before starting the exercise, please ensure that you are logged out. Okay, let's do that. On this is the attacker side. Let me just go with the actual one. Okay, we are logged out, and let me do the same here as well. It is not there anymore. Yeah, we are logged out. There was a dot at the end, so I will just close everything here. Okay, all right. In the attached VM, visit factbook.thm 8080. Do we need to add this one as well, or it is available out of the box? They are saying attached VM, so attached VM is here. Let's visit this website. Okay, sync statuses from the coffee shop app. Click the button below to sync your statuses using OAuth. We will not, unless they will tell us to do. Machine expiring soon. Which one? What about the attack box? Is this attack box expiring soon as well, or what? Just a moment, guys. I already added 1 hour, so I'm not sure which machine they are trying to tell me about. So let's move forward. In any case, we are good to go. Okay. Where you will see the page that allows you to sync your statuses from the coffee shop app. The authorization process will start once you click on the sync status from the coffee shop app button. The client application is configured to use the implicit grant type, which means the access token will be directly returned to the client. The authorization URL is constructed as below. So this is how the client ID is there. As you can see, the client secret is not there because we are using this implicit grant flow. Redirect URI, auth URL is there, and then the final URL is there in order to redirect, but we are encoding the redirect URI. And this is the victim perspective. Once the user authenticates using the OAuth provider credential victim 1 to 3, he will be redirected to the callback.php where he can enter his status. This page includes a form for entering a status, submitting it via AJAX request. So because there is a button for submitting a status, and here is the PHP code for submit. Wait a moment. We are just submitting the status, but where is the text box, man? I don't know. Okay, so these are the submitted statuses, and this is a JavaScript. I don't know where it is. Okay, this is start session. In here is set. If the status is set in the post request, we will get the status and send the JSON back, as you can see, and then we exit. Display previously stored statuses. So this is how, if the status is set, then we loop through all the statuses and just echo one item at a time. For the demonstration purposes, status input field is vulnerable to XSS. Once you reach the status page, enter a status like hello. Okay, so before we do that, we need to call back .php. On the other side, provider credential. Okay, so okay, let's click on it, and we will use the victim, and victim123 login. I will authorize, and here is the status. Let's put hello for now. Okay, the status is shown back on the page. This is the very bad practice, unless you validate the payload on the even the client side and also on the server side, because this is the AJAX call. That means we are calling an API to do all of this. Okay, attacker perspective. To prepare for the attacker, inside the attacker box instance, run a Python HTTP server to listen on the port 8081 using the command python 3. So let's do that. So this is our attack box. So here we need to run, because we are already in the root, we need to run the server. So what is the command exactly? -m. Okay, so -m is server. We are using server.http or http.server. What is the http.server? http.server, and port is 8081. Yes, I'm not copy pasting just to make sure that I understand, and don't forget the command later on. Okay. Okay, the attacker will share the following payload with the victim. So we need to change the attacker box IP address here, otherwise everything is okay. So let's do that here. Let me open up a new tab. So let's go with script.txt. I'll copy paste here. Only thing I need to mention is the IP address. So there are many ways to get the IP address. The fastest way is that the attacker box IP address is available in the header here. So I'm gonna just enter 10.10.196.209, and then I will press Ctrl O to write O and press enter, and Ctrl X to exit it. Once I cat this script, as you can see, everything is okay. Now we can just copy this one. All right. So we have prepared the script here. This JavaScript payload start by extracting the fragment identifier from the URL. Okay. Which is the part of the URL following the simple hash. So this is how we are going. So location dot hash, and then we are substringing it. It removes the leading hash using the substring 1. Okay, to obtain the raw fragment string. This string is then splitted by AND sign here. Then we are to separate the individual key value pair. The reduce function processes each of these pairs, and splitting them by is equal to isolate the keys and values. These key value pair are then stored in the object called result. We are reducing, so reduce will have a function. It will have res and item. What parts is equal to item.split is equal to, and the result, we are putting the value back to the result by an index. As you can see, part 1, part 0 will have some value as part 1, and then return the result. Then we are returning the array back. So this will be available in the hash, and then we are declaring access token is equal to result.access token will be available. Where is the, okay, this is the result here, sorry. So it will be stored in the result. So result.access token will have the access token, and then we are creating a new image, and that image.source will be this one, which basically will call the URL with the access token. Okay, so the access token will be available inside here. Okay, so let's move on. Copy paste the code inside the victim's machine into the status input field. Once the victim refreshes the page, the access as payload is executed. It copies the access token from the URL fragment and send it to the attacker server at the IP address like this. The attacker can then capture the token and use it to gain unauthorized access to the user's account. Refresh the page in order to visualize the victim sees and to retrieve the tokens. Okay, so this is the victim. Let's put another status. I will copy paste. Okay, where is the copy? I need to copy from here. I think any kind of pad is available. Mouse pad. So previous session. I will just paste here. Now I will copy from here again, because cross VM copy pasting was not working, so I'm doing it like this. Now copy should be in the clipboard, should be shared as well. Why it is not working? Okay, I just put the control V and it worked. I will submit it. As you can see, there is a new row here, but nothing happened. And if I go back here, nothing happened as well, unless we refresh this page. Once I refresh, now the JavaScript has executed, and here we have the token available. So let's copy this token, go back. What symbol separates the access token from the implicit grant workflow? So it is pound. Visit the URL flag validator and enter the access token you acquire. What is the flag value? Okay, so let me copy this URL. Here, paste and go. Now we need to enter the. Wait a moment. The token itself. Here is the token. We will copy and I will put it here, paste and submit. Let's see if it is validated. It is validating. Okay, so we got the flag here as well. Let it complete, and then we will be able to copy and paste here. Awesome. We are moving to the task 9. Other vulnerabilities and evolution of OAuth 2.1. It is not practical. It is just the information here. So let's go through it. Apart from the vulnerability discussed earlier, attacker can exploit several other critical vulnerabilities in OAuth 2.0 implementations. The following are some additional vulnerabilities that pen testers should be aware of while pen testing an application. Insufficient token expiry. Access token with long or infinite lifetimes pose a significant security risk. If an attacker obtains such a token, they can access protected resources indefinitely. Implementing the short-lived access and refresh token helps mitigate this risk by limiting the window of opportunity for an attacker. Awesome. Replay attacks or replay attacks. Replay attacks involve capturing valid tokens and reusing them to gain unauthorized access. Attacker can expire token multiple times without mechanisms to detect and prevent access token reuse. Implementing nonce, value, and timestamp checks can help mitigate the replay attacks by ensuring each token is used only once. Okay. So these are implemented by default in OAuth 2.1, by the way. Insecure storage of tokens. Storing access token and refresh token insecurely in local storage or unencrypted files can lead to token theft and unauthorized access. Using secure storage mechanisms such as secure cookies or encrypted databases can protect tokens from being accessed by malicious actors. That is very true, but sometimes you need to store the token in the local storage. Evolution of OAuth 2.1. OAuth 2.1 represents the latest iteration in the evolution of OAuth standard, building on the foundation of OAuth 2.0 to address its shortcomings and enhance security. The journey from OAuth 2.0 to OAuth 2.1 has been driven by a need to mitigate known vulnerabilities and incorporate best practices that have emerged since the original specification was published. OAuth 2.0, while widely adopted, had several areas that require improvement, particularly in terms of security and interoperability. So the major changes are: OAuth 2.1 introduced several key changes and aimed at strengthening the protocol. One of the most significant updates is the deprecation of the implicit grant type, which was identified as a major security risk due to token exposure in the URL fragment. Instead, OAuth 2.1 recommends the authorization code flow with the PKCE for public clients. Additionally, OAuth 2.1 mandates using the state parameter to protect against CSRF attacks. That is true. OAuth 2.1 also emphasizes the importance of secure handling and storage of token. It advises against storing token in the browser local storage due to the risk of CSS attacks and recommends using secure cookies instead. Moreover, OAuth 2.1 enhances interoperability by providing clearer guidelines for redirect URI validation, client authorization, and scope validation. Okay, machine is expired, it's okay. In summary, OAuth 2.1 builds on OAuth 2.0 by addressing its security gaps and incorporating best practices to offer a more secure and protected authorization framework. For more detailed information on OAuth 2.1, you can refer to the official specification. I will take a look behind the scene. Let's move forward. Answer the following question: which of the following has been omitted from OAuth 2.1? It is implicit grant, which is A. Submit. Awesome. So we are on the task 10, conclusion. In this conclusion, the room on the OAuth has provided a detailed understanding of OAuth 2.1, its significance in modern web applications. We discussed the fundamental concept necessary to understand OAuth, including various grant types and OAuth flow. We then explored how to identify OAuth services within a web application. Through practical exercises, we exploited various vulnerabilities associated with the OAuth 2.0, including weak implementation of the implicit grant flow, the effects of unmanaged redirect _URI, and the non-availability of the scope parameter. These exercises highlighted the critical nature of securing OAuth implementation and the potential risk of common means configuration. misconfigurations. Finally, we examined other vulnerability and discussed the evolution of OAuth 2.1, emphasizing its improvement and how it addresses the shortcoming of OAuth 2.0. This room has equipped you with the knowledge to identify and mitigate risk associated with the OAuth from the lens of pen tester and secure coder. Let us know your thoughts on this room on our Discord channel or X account. See you around. Awesome. Once you click on complete, congratulations guys, we have completed another amazing premium room on TryHackMe.com. Thank you guys for joining me on this journey. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe to the channel. And if you have any suggestion for improvement, let me know in the comments below. And if there is any room you want me to cover on TryHackMe.com, let me know in the comments below as well. And I will see you in the next video. Thank you very much.